In this part of the code, I'm gonna guide you through the gap filling process based on maps. So this is a process that I use quite a lot in my research, which is when I'm facing a new database, sometimes comes with some empty slots, some NAs in the data, and I wanna fill them based on field data. Obviously, data coming from maps is not as accurate as data coming from field experiments, but this is a good proxy we have to maximize the data we have and use them all in our models. So what I'm going to be doing here is to use the latitude and longitude of the coordinates that comes into the databases, transform them into spatial explicit data points, and use these data points to extract the data coming from a map. So let's just go ahead. I'm going to download real data that I created that is in my GitHub account. You can download it freely here. It's a database that calculates nitrogen uptake global scale based on field data. But I encountered that some of the drivers, temperature, precipitation, soil information has not always been collected, or maybe wasn't reported in the original papers. So that's why there are some data gaps. So, well, you can see that it's a big database. It includes a lot of columns. Some of them are complete. Some of them have NAs. So I'm just going to see how are they called. These are all the names of the columns. And we are going to be particularly interested in the latitude and longitude, which is the third and fourth column right here. I'm going to make sure that we don't have NAs there. So I'm just going to subset the data that doesn't include NAs. So it says is NA, so that doesn't include NA in the latitude, and it doesn't include NAs in the longitude. This is one of the several ways we have to make sure that we exclude NAs in these particular columns. Okay, now that we have this sorted out, there are two ways of transforming these data points, so this latitude and longitude, in data explicit points. One is using spatial points here, and the other one is using spatial points data frame. In both of them, I need to specify where latitude and longitude are located, what's the database that I'm using, and in the first case, I need to specify also the resolution I want the data to be. I personally like this more. But with this one right here, it's gonna also work for our purposes right now. We see that the outcome we get is slightly different. One is spatial points data frame and the other one is spatial points. But if we plot them, they look very similar. So, and we can plot them with the shape of the Earth, just to have a good understanding of what is this plotting. Here I added this map that we already used in other parts of the videos. So here we can have a good understanding of where this data is coming from. And it also certifies that we have built our map appropriately. Sometimes if you mismatch latitude and longitude, you're gonna have like a twisted map. So let's just try it for fun. Let's see how it looks like. You see, now it's totally changed 90 degrees, but just a heads up to put latitude and longitude in the appropriate location. Okay, so going back to the process, I'm going to use as the base this map that we've been using recurrently, which is this temperature map, and I want to extract the information using these points. So I only need to use the function extract, the map where I want to take the information from, and the points I want to use to extract the data. So I use this, and I see that the result is this right here. Oh, sorry. Here, and we see that we have a new value here, a new vector, that it's 159 data points long, which is exactly the same number of columns, of rows, sorry, we have in our data frame. And if we, instead of having one map here, we would have had a stack or a brick, we would have had a column per map. So in this case, we only have one because we have one map, but the more maps we have, the more columns it would add in our result. Now I'm gonna guide you through an exercise that hopefully is gonna be a good summary of all the functions and all the concepts we've been working with in this GIS session. I'm gonna guide you through it. So initially there's nothing done here, so I'm gonna type while doing it live. And first of all, I would ask you to download these 10-meter resolution average temperature maps from WorldClim. This is the link, but in case you don't have it handy, this is how the web page looks like. I would ask you to go to this average temperature and download this one. Feel free to download other resolutions as well, but I just went to the course one to make the explanation more fluid and the calculations easier to calculate. So it's download this, store it somewhere in your computer that you know the route of. And also I'm going to ask you to load all these maps in your R session and calculate the average of all the maps, so to obtain the yearly average temperature. Okay, to do that I'm going to use code that we've already used. I'm just going to jump around. I think I have this code here. Yes. I'm going to use this. So I'm going to charge everything at once. Instead of going one by one, I'm going to do it faster. This and this. I don't really want this code here. I'm going to create a stack of these. And now I want to calculate the mean of all these maps. So to do that, it's going to be called I'm going to use this object here. And calculate the mean. This is what we got. So see that the information looks good. The values, minimum, the maximum, they look feasible. So it seems that everything worked out pretty well. I'm just going to plot it to see how it looks like. So yeah, it seems reasonable. So I think we've successfully completed the first step. Second step. I want you to download the nitrogen uptake data from this page, which is my GitHub page. This is the database we've used in the previous exercise, so you might have it already. And I'm going to ask you to create a new data frame by subsetting the columns number 3, 4, and 18, which are the latitude, longitude, and mean annual temperature, which is what we just calculated in our maps. So to do that, just gonna load the data that should have here. This is the data. I'm gonna subset I set the column number 3, number 4, and number 18. Now we have this object that has exactly the same length, so the same rows, but these 3 variables that I asked you for, latitude, longitude, and mean annual temperature. I chose this variable because we have some NAs, as I mentioned. You see some empty values that we would like to fill in further steps. Okay, let's move on to the step 3. I want to create spatial points by using the coordinates in the subsetted data frame. And I also want to extract the mean annual temperature of the data points you just created from the map and include them in a new vector to the data frame, resulting in a 4-column data frame. So, I'm gonna go through the code that we just used. Oops, sorry. Gonna find them here. This one. I'm gonna use this one that's shorter. Okay, we created that, and now we want to extract this information. So it's going to be called MAT, stands for mean annual temperature, and I want to extract from this variable that we created, that's the mean temperature. And the PNT. Okay, we created this vector here, and now I want to add this vector to our initial data frame. So our data frame was called this. It's gonna be called, coming from World Claim. This is one way to do it. There are other ways, so if you find an easier way that works better for you to do it, feel free. So now we had this initial database that had only 3 columns. Now it has 4 columns, and we just added this new column here with a new variable. We could even see how these two match. So this comes from ground measurements, so it's based on field data, and this is the map. We could even see how these two match. We could, for example, plot these two informations or create a linear model. They're just going to go with the model. It's going to be called Model 1. It's going to be a linear model where I have these. Based on our claim, this data is gonna be this one. Let's see, well, it's almost the same data. So they agree in a 94%. Yes, almost 1, the perfect regression. So this is a good proxy. We could also plot them in a linear in a regression plot. It's just it's like this, and we see how the data mostly agrees. Okay, and now finally I want to combine these two columns. So create a new column in your data frame where you gap fill the mean annual temperature variable with the map data you just extracted. So what I want to do here is to use, so mainly use this field experimental data, but use the map to gap fill these empty spaces that I have here. To do so, I'm going to use code that I already have, which uses a for loop. So it's faster. Okay, what I'm doing is to this data. I'm gonna change the code using this tool. So what initially was general DB now is going to be called and in the section, which is what I selected, and replace them all. Yes, for occurrences. Okay, and now the data. So what I'm going to be doing is I'm asking R to generate this for loop that goes from 1 to 159, which is the number of rows that I have. And I'm saying if this is NA, so it's an empty space. If this variable is an empty space, go to the same variable and fill this space with what you will find here. And if that's not an NA, just leave it like is. You could even erase this part. So like we could not need this else part because it's basically leaving the thing as they are. So you could decide to erase this and things would work either way. So I'm gonna make this run. Maybe it gives us some error. It seemed that it went smooth. Okay. Now we see that this variable here doesn't have NAs because we filled this information with the information coming here. In this case, I have destroyed the initial variable, meaning that now we no longer have the variable with these spaces. I could have created a new variable, which is what I'm gonna do now, just for you to see it and to compare things better. So I'm gonna rerun the whole code in a very easy way. Like this, these are the advantages of R, that you can rerun things pretty easy. And now instead of rearranging things on top of the variable that already existed, I'm going to create a new one that's going to be called new. New. Going to redo the process. Now we have this new code, this new column here, and so when we have an NA, it's always the same as MAT, but in the ones that we have NA, we've used this one instead. And this is a very efficient way that we have to gap fill data coming from map data.